Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on microservices. This will be a lengthy explanation with code examples to illustrate key concepts. We'll cover the fundamentals, design principles, communication strategies, deployment considerations, and some important best practices. What are microservices? At its core, a microservices architecture is a design approach where a single application is composed of many small, independently deployable services. These services communicate with each other over a network, often using lightweight protocols like HTTP or grpc. Each service represents a specific business capability. Why microservices? Advantages. Independent deployability. Each service can be deployed, updated, and scaled independently without affecting the entire application. This leads to faster release cycles and reduced risk. Scalability. Individual services can be scaled based on their specific resource demands. You can scale the services that handle high traffic without scaling the entire application. Technology diversity. Teams can choose the most appropriate technology stack, language, database, framework, for each service, promoting innovation and agility. Fault isolation. If one service fails, it shouldn't bring down the entire application. Other services can continue to function, potentially with graceful degradation. Team autonomy. Smaller, focused teams can work on individual services, leading to increased productivity and ownership. Improved maintainability. Smaller code bases are easier to understand, maintain, and debug. When not to use microservices. Simple applications. For small, straightforward applications, the complexity of microservices might outweigh the benefits. A monolithic architecture might be more suitable. Lack of DevOps maturity. Microservices require a strong DevOps culture with automated deployment, monitoring, and infrastructure management. Immature domain understanding. If the business domain is not well defined, breaking it down into microservices can be premature and lead to tightly coupled services. Core principles of microservices. One single responsibility principle, SRP. Each microservice should have a well-defined, single responsibility. It should do one thing and do it well. 2. Bounded context. A microservice operates within a specific bounded context, which is a conceptual boundary within the domain. This helps to define the scope of the service and prevent it from becoming too large. 3. Independent deployability. Each service should be deployable independently without requiring changes or deployments of other services. 4. Decentralized governance. Teams should have autonomy over their services, choosing the technologies and practices that best suit their needs. 5. Automation. Automated deployment, testing, monitoring, and infrastructure management are crucial for the success of a microservices architecture. 6. Design for failure. Microservices should be designed to handle failures gracefully. Implement patterns like circuit breakers, retries, and fallbacks. 7. API first design. Every microservice exposes an API for communication and integration with other microservices. These APIs should be versioned. Example scenario: e-commerce application. Let's consider a simplified e-commerce application and how it could be broken down into microservices. Product catalog service. Manages product information, name, description, price, images, etc. Order service. Handles order placement, tracking, and management. Customer service. Manages customer accounts, profiles, and addresses. Payment service. Processes payments through various payment gateways. Asterisk shipping service asterisk handles shipping and delivery logistics. Asterisk inventory service asterisk manages product inventory levels. Asterisk recommendation service asterisk provides product recommendations to users based on browsing history. Communication strategies. Microservices communicate with each other over a network. There are two main communication styles. One, synchronous communication, request/response. Asterisk a service makes a request to another service and waits for a response. Asterisk typically uses HTTP/REST or grpc. Asterisk suitable for scenarios where a response is needed immediately. Asterisk example using Python Flask and requests library asterisk. Asterisk explanation asterisk. Asterisk product catalog service asterisk a simple Flask app that exposes a/products endpoint. Asterisk order service asterisk receives a post request to /orders. It uses the requests library to make an HTTP GET request to the product catalog service to retrieve product details. Error handling is included to catch potential issues with the external service. The response.raise_for_status method is crucial for checking HTTP status codes. 2. Asynchronous communication, message queue. Asterisk services communicate through a message broker, example RabbitMQ, Kafka, AWS SQS. Asterisk a service publishes a message to a queue, and one or more other services subscribe to that queue and process the message. Asterisk suitable for decoupling services and handling asynchronous tasks. Asterisk allows for eventual consistency. Example using RabbitMQ and Python, Pika library. Asterisk explanation asterisk. Asterisk publisher, order service connects to RabbitMQ, declares a queue named order_created, and publishes a message containing order information. Asterisk consumer, shipping service connects to RabbitMQ, declares the same queue, and starts consuming messages from it. The callback function is executed whenever a new message arrives. Basic_ACK is important to ensure that messages are not lost if the consumer crashes during processing. Basic_QoS allows you to limit the number of unacknowledged messages that a consumer can have, improving resource utilization. Important considerations for communication. Idempotency ensure that your services can handle duplicate messages or requests without causing unintended side effects. This is crucial in distributed systems where network issues can lead to retries. Consider using unique IDs for each message. API versioning as your services evolve, you'll need to update their APIs. Use versioning, example v1, v2 in the API path or header, to avoid breaking existing clients. Circuit breaker implement a circuit breaker pattern to prevent cascading failures. If a service is failing repeatedly, the circuit breaker will open, preventing further requests from being sent to that service. This gives the failing service time to recover. Deployment strategies. Deploying microservices can be challenging. Here are some common strategies. 1. Virtual machines, VMs. Each service is deployed in its own VM. This provides good isolation but can be resource intensive. 2. Containers, Docker. Each service is packaged as a Docker container. Containers are lightweight and provide a consistent environment across different platforms. Docker containers are often orchestrated using tools like Kubernetes or Docker Swarm. 3. Serverless, AWS Lambda, Azure Functions, Google Cloud Functions deploy individual functions that execute in response to events. This is a highly scalable and cost-effective option, but it can be more complex to manage. Kubernetes deployment example, YAML. Here's a basic example of a Kubernetes deployment YAML file for the product catalog service. Explanation deployment defines how many instances of the product catalog service should be running, the Docker image to use, and the ports it exposes. Service exposes the deployment as a network service. The load balancer type makes the service accessible from outside the Kubernetes cluster. You'll need to replace your Docker Hub username / product catalog latest with your actual Docker image. The value of database _URL env is replaced with your database URL. Monitoring and logging. Effective monitoring and logging are essential for managing a microservices architecture. You need to be able to track the health of your services, identify performance bottlenecks, and troubleshoot issues. Centralized logging collect logs from all services into a central location, example Elasticsearch, Splunk, Graylog. Metrics collect metrics about service performance, example response time, error rate, resource utilization. Use tools like Prometheus, Grafana, or Datadog. Distributed tracing track requests as they flow through multiple services. Tools like Jaeger or Zipkin can help you identify latency issues and dependencies. Health checks implement health check endpoints in each service that can be used to monitor its availability. Kubernetes uses health checks to determine when to restart containers. Security considerations. Authentication and authorization implement robust authentication and authorization mechanisms to protect your services. Use standards like OAuth 2.0 and OpenID Connect. API Gateway use an API gateway to handle authentication, authorization, rate limiting, and other cross-cutting concerns. Service mesh a service mesh, example Istio, Linkerd, can provide security features like mutual TLS authentication and traffic encryption. Network policies use network policies to restrict communication between services. This can help to prevent lateral movement in case of a security breach. API Gateway. The API Gateway acts as a single entry point for all client requests. It handles routing, authentication, authorization, rate limiting, and other cross-cutting concerns. This simplifies client development and improves security. Benefits centralized point of entry provides a single, unified interface for clients. Security handles authentication and authorization, protecting backend services. Rate limiting prevents abuse and ensures fair usage. Request routing routes requests to the appropriate backend service. Transformation can transform requests and responses to match the client's expectations. Popular options Kong an open source API gateway. Tyke an open source, cloud native API gateway. AWS API gateway a managed API gateway service from AWS. Azure API management a managed API gateway service from Azure. Service discovery. In a microservices architecture, services need to be able to discover the location of other services. Service discovery mechanisms provide a way for services to dynamically locate and communicate with each other. Client-side discovery the client, the service making the request, queries a service registry to find the location of the target service. Server-side discovery the client makes a request to a load balancer, which then forwards the request to an available instance of the target service. Tools and technologies. Languages Java, Python, Go, Node.js, .NET. Asterisk frameworks asterisk Spring Boot, Flask, Express.js, ASP.NET Core. Asterisk message brokers asterisk RabbitMQ, Kafka, AWS SQS, Azure Service Bus. Asterisk API gateways asterisk Kong, TYK, AWS API Gateway, Azure API Management. Asterisk service meshes asterisk Istio, Linkerd. Asterisk orchestration asterisk Kubernetes, Docker Swarm. Asterisk monitoring asterisk Prometheus, Grafana, Elasticsearch, Kibana, Jaeger, Zipkin. Best practices. Asterisk start small asterisk don't try to build a complex microservices architecture from the beginning. Start with a monolithic application and gradually break it down into microservices as needed. Asterisk domain-driven design, DDD. Use DDD to identify bounded contexts and define the boundaries of your microservices. Asterisk automate everything asterisk automate deployment, testing, monitoring, and infrastructure management. Asterisk design for failure asterisk implement patterns like circuit breakers, retries, and fallbacks to handle failures gracefully. Asterisk embrace DevOps asterisk foster a DevOps culture with collaboration between development and operations teams. Conclusion. Microservices are a powerful architectural pattern for building complex, scalable, and resilient applications. However, they also introduce significant challenges. By understanding the principles, communication strategies, deployment considerations, and best practices outlined in this tutorial, you can increase your chances of success with microservices. Remember to start small, automate everything, and design for failure. The code examples provide a basic foundation, but real-world microservices applications often require more sophisticated implementations. Experiment and learn from your experiences.